Dear students, now we will discuss the Kohlrausch law. The Kohlrausch law is useful for the find out lambda 0 value for weak electrolytes. Okay. Lambda value means the equivalent conductance. Okay, lambda is the equivalent conductance at any concentration. But when you dilute the solution, okay, as you dilute the solution, okay, we discuss your lambda value is increases, and at a particular dilution lambda value is not increases, that is limiting value. Okay, after that lambda value is not increases, that limiting value from where you add the water, anything add after any dilution, no lambda value is increases, and that limiting value is called as the lambda 0, and that equivalent conductance at a infinite dilute solution. Infinite dilute solution means, if you consider infinite dilute solution, very dilute solution, highly dilute solution means the concentration is very low, and basically we take the concentration very low is C is equal to 0, means concentration is totally 0, no electrolyte is there, that term is the meaningless. Okay, that concentration is the meaningless. What is meaning of the infinite dilution? Infinite dilution is not mean the C is equal to 0. Infinite dilution means what? When you have electrolyte and you added solvent and it gets dilute. You added more, at firstly added second, third, fourth, okay, like that 0.1 dilute, 0.2 dilute, 0.05 dilute, okay, by adding not 5, okay, you added water inside it. As you added the water, its conductance goes on increases, 1, conductance 2, conductance 3, it goes on increases. But when you add a particular dilution, at that point your lambda value, that is you obtain lambda 0, further addition of solvent, the lambda value is not increasing, and that particular lambda value is you consider as a lambda 0. Okay, and that solution is a infinite dilute solution. Okay, C is equal to 0 is not considered as a infinite dilute solution. Okay, in previous lecture we have one graph also we plotted. That graph is from the equation lambda is equal to lambda 0 minus B under root C. Okay, under root C, that is concentration increases, lambda is increases. You found that for strong electrolyte your concentration is decreases, that dilution increases, your value is increases. Okay, but you not get to the infinite dilute, not C is that point is C is equal to 0, like that point we not obtain. Therefore for strong electrolyte, if you obtain such graph but you extrapolate it, okay, you by using the scale you extrapolate it, that point you obtain lambda 0, that is limiting lambda value. After that your lambda value is not increases for strong electrolyte, but when you dilute the weak electrolyte it increases like that, but it not extrapolate this. Okay, by have to extrapolate to intercept this one. Therefore for weak electrolyte, by using this equation, line equation, we will not obtain the lambda 0 values, that is limiting lambda. At very dilute solution, what is the values of weak electrolyte we will not obtain from using this graph. Therefore we have Kohlrausch equation. By using the Kohlrausch law, we can find out the lambda 0 values also for weak electrolytes. What is meaning of Kohlrausch law? What is law of Kohlrausch? We will discuss. If suppose we have a electrolyte is there, okay, If suppose KCl is there, K plus and Cl minus. Then we'll see the statement later, but before going to the statement, that is the one of the table we have already written here, and we found that the equivalent conductance of Kcl is like that, NaCl is like that, and okay, that's chlorine is the same thing. Okay, chlorine is same thing when you difference take. This chlorine is okay, difference means what? K plus Cl minus, then minus Na plus, and Cl minus. Okay, that Cl is will get outside. K plus minus Na plus. Okay, that difference is always is 21.1, and that is also 21.1. Okay, for Na3 that is cancel. Difference between K and Na, K plus and Na. Okay, NO3 minus charge, Cl minus is there. The K plus, Na plus, the difference between K plus and Na plus lambda 0. Okay, that is limiting at lambda at that is lambda 0. That is called, what you call the lambda 0? Lambda 0 is the equivalent conductance at the infinite dilution. Okay, that is very high dilution is there. In this case also K minus, K plus and the Na plus lambda 0 is 21.1. Okay, and for this is also K2 is Na2 is there, but we take 1/2, then it is K, and 1/2 Na2 is connected to Na. Therefore the value is also 21.1. Okay, it means the K plus lambda 0 value is fixed and Na plus lambda value is fixed. Then and then this difference is came. Okay, therefore at very dilute, okay, that lambda 0 is the very dilute situation. Lambda 0 is the equivalent conductance at a very dilute solution. Okay, therefore at very dilute solution the K plus value, okay, K plus value, lambda 0 K plus value is a constant one. Okay, and so lambda 0 Na plus value is constant. Okay, any ions. Okay, lambda 0 value is a constant. Okay, for at a very dilute solution. Okay, therefore the migration of any ion, so if there is a positive migration of K plus or cation or anions is independent on its co-ion. Okay, co-ion Cl minus is its co-ion. Therefore migration of this K plus is independent on Cl minus, its co-ion. And to total equivalent conductance. Okay, for this K plus lambda 0 is the Kcl, something value is obtained. Okay, for Kcl, okay, Kcl 130 is value is obtained. This is and to the total equivalent conductance. Okay, to this 130, the total equivalent conductance, that ion share a individual equivalent conductance. Okay, equivalent conductance. Okay, it is having the a particular equivalent conductance. Okay, that equivalent conductance contributes to the total equivalent conductance of an electrolyte, a definite share. Okay, it share a equivalent conductance to total equivalent. Okay, definite. Okay, definite share conductance, and it depends upon its nature. Okay, it depends upon its nature. Okay, its nature means what? Its size or different parameters. Its size is mostly size, how much charge. Okay, it depends upon its nature, not depends upon its co-ion. Co-ion means the second. Okay, K plus is its co-ion is Cl minus. Okay, not depends upon its co-ion, not depends upon its co-ion. Okay, therefore this K plus ion shares a equivalent conductance to total equivalent conductance, and it depends upon its nature, not depends upon its co-ion. Okay, firstly it migrates its own. Okay, it migrates to negative electrode, is independent on its co-ion, that is Cl, it not depends upon Cl minus ion. Okay, and it shares the total equivalent conductance, that contributes to the total equivalent conductance, a particular share, particular equivalent conductance share, and it's not depends upon its nature. Okay, that is the our law. Okay, why this is happen? Because at very infinite dilution, the inter-electronic interaction is very negligible or very less. Okay, therefore there is attraction is very negligible. Okay, therefore these two are not effects with each other. We very away from each other. When you dilute means K plus and Cl minus goes very away from each other. And for a particular, it is having a particular lambda 0 value, it is having particular lambda 0 value. It not depends to each other. Therefore, when you calculate the lambda 0 for Kcl, therefore you can take the L0 for K plus and L0 for Cl minus. By summation of these, you will obtain the equivalent conductance of Kcl. This is the law of the Kohlrausch. Okay. Therefore, it's useful for find out lambda 0 for the weak electrolyte, limiting value of lambda for weak electrolyte. Okay, how it is calculated? First method is individual summation of the equivalent conductance. Okay, lambda individual summation of lambda 0 values, and you will find by using the Kohlrausch law. You by summation, directly summation of this particular individual lambda 0 values, you will obtain the total lambda 0. For example, if you obtain CH3COH lambda 0 value, then for this lambda L0 for H plus ion plus L0 for CH3COO minus. Okay, by summation of this, okay, we have the from the literature we will obtain this value. For H plus we have value 349.82 plus. For CH3CO minus 40.90 value. By summation of this, you will obtain the lambda 0 value for the CH3COH. Okay, that is the summation. Very easy method by using the summation method. Okay, the second method you can find out, that is the arithmetic method. Okay, you want to find out the lambda 0 value for this. Then you firstly by addition and the subtraction you will find out the actual value of this. Okay, for this we have the two parts. Okay, first part is that you made it strong acid, therefore HCl. For this second part you made the strong salt, okay, Na, and that point this you will make the third one, okay, NaCl. Okay, therefore firstly you CH3COO Na, okay, lambda 0 minus plus lambda 0 for HCl minus lambda 0 for NaCl. Okay, like that method you will obtain lambda 0 for CH3COO. Okay, summation. Okay, like that lambda 0, if you ion is there, okay, it's by the separation minus plus lambda 0 for Na plus lambda 0 for H plus lambda 0 for Cl minus plus minus lambda 0 for Na plus lambda 0 minus lambda 0 for Cl minus. Okay, Na plus is cancelled, Cl minus is cancelled, therefore you have the CH3CO minus and the H plus. Okay, by adding, okay, first you have the value of lambda 0, then add HCl value and minus NaCl value. Okay, all these are the strong electrolytes. Okay, strong electrolyte we have the lambda 0 for, but weak electrolyte we have not the lambda 0 values. Strong electrolyte we have available these values. Okay, therefore that values you have available, that values or total value is also available. Therefore you add this value plus this value and minus lambda 0 of NaCl. We will obtain the value of lambda 0 for CH3COH minus, that is a weak acid, weak electrolyte. Like that, there is the two method, very simple method. First is the direct addition of the lambda 0 values of different cation anions, and second is the subtracting addition of the weak strong electrolyte, okay, which is made which is related to that particular weak electrolyte. Okay, the particular things, these 3 points is related to that points, that electrolyte. Therefore you have to find it which actually for this HCl we have taken, for this CH3CON taken, and when the minus you will obtain CH3COH values you will be there. Like that way you have to manage. By subtracting addition you can obtain the lambda 0 value. Okay, this is all about the Kohlrausch law. Thank you very much.